All right, so today we are starting Unit 2, Section 2, which is all about slope. We want to be able to find the slope between 2 points and identify the slope from a graph, such as this one in the right-hand corner. So when we are talking about slope, we are going to be looking at linear functions. Okay, linear function. So a linear function is any situation that changes at a constant rate. And here we have some examples. So you get $5 each week. This week you get $5, next week you get $5. It's a constant rate that makes it linear. If we are looking at our table of values, well, from 5 to 7, we go up by 2. From 7 to 9, we go up by 2. From 9 to 11, we go up by 2. 2 is our constant rate of change. When you're looking at a graph, if you have a straight line, that is linear. Notice how when you look at linear, the word line is in there, right? So a straight line, linear. When we are looking at an equation, okay, mostly we'll be seeing ones that look like y equals mx plus b, linear if it has a degree of 1. So this x right here has a degree of 1. In other words, it's to the first power. We also have some examples of non-linear. So these are not linear, which means they are not constant. They do not change at a constant rate. So if you double the amount you are saving each week, this week you'll save 5, next week you'll save 10, the week after that you'll save 20. That rate is changing, so it's not constant, it's not linear. Same for our table. Well, 2 to 5 we change by 3, 5 to 11 we change by 6, 11 to 20 we change by 9. These are not the same numbers, so it's not linear. When we're looking at a graph, anything that's not a straight line is not linear. And we're looking at an equation, anything that is not, where the degree is not 1. So here our degree is 2, here our degree is actually 1/2, here our degree is 3. So those are examples that are non-linear. So we're going to be talking about slope-intercept form. This should be a familiar concept. You talked about this a lot last year in your math class. So slope-intercept form, we have this special equation, y equals m times x plus b. Y equals mx plus b. We will be using this a lot throughout the semester. So hopefully this sounds a little bit familiar, and we are going to look at some of the properties. Okay, so our m variable is our slope. All right, our slope, the definition is our rate of change. So it's telling us how our function is changing. Okay, our slope also describes the angle and the direction of the line. All right, so is it increasing? Is it decreasing? Is it a steep line? Is it a more gradual slope? So it's this would be an example of steep. This would be an example of more gradual. So those are all things that slope can tell us. B is the same thing as our y-intercept. So if we are looking at a graph, we are looking at our xy plane. Wherever your graph touches the y-axis is your y-intercept. Okay, it's where your graph is intersecting that y-axis. So this is the starting value in a situation. So maybe you're saving money and you're starting with the $20 you got for your birthday. The point where the line crosses the y-axis is the same as where x equals 0. So your y-intercept can always be expressed as the point 0, v. So 0 and then whatever your specific y value is. There are 4 different types of slope. All right, so the first type of slope, for example, is when our slope equals 1. Well, 1 is a positive number. Positive slope. So if we draw a line that is going up, this has a positive slope. It is changing in a positive direction. Well, we could also have a slope where m is equal to -1. So when m is equal to -1, that is a negative slope. We also have the situation where our slope is 0. Let's make it sound like that's when m equals 0. That is just a horizontal line. A horizontal line. So if we're looking at our equation, well, y equals 0 times x minus 4. So an equation with a 0 slope actually doesn't have an x in it. This equation is just y equals -4. Last but not least, we have undefined slope. So if there's no m, okay, undefined slope and equation would be, for example, x equals some number. So we have x equals 1. That would be the vertical line where x equals 1. Those are our 4 types of slope. Parts of a linear function. So our slope, again, it's that constant rate of change. We have those 4 types. It tells the angle and direction of a line. Slope is also known as rise over run. So we'll use this a lot. M equals our rise over our run. Okay. Rise is how high or how far up or down your equation is going. Run is how far from side to side your equation is going. Okay, and then we'll also be using this formula down here in just a minute, or y2 minus y1 divided by x2 minus x1. That is another way to find the slope. So we can find a slope from an equation, from a graph, or we can find it if we're given 2 points. So if we are looking at an equation, remember our formula y equals mx plus b. Well, since m is our slope, to find the slope in an equation, all we do is look for what is in the spot of our variable m. In this case, it's -2/3. So instead of m times x, we have -2/3 times x. That's our slope. So we would write m equals -2/3. That is our answer. If we're looking at a graph, that's when we're talking about our rise over run. So we are looking at any point. So I'm going to pick this point 0, 3. 0, 3 is the point I'm looking at. And to find the rise over run, I want to figure out how far up or down, and then how far over I have to go to get to the next point. So to get to the next point on this graph, I go up 2, and I go over 1. So up 2 over 1. Remember, up is our rise, over is our run. So our rise over run is the same as 2 over 1. And 2 over 1 simplifies down to 2. So our slope is 2. We can also find the slope if we are given 2 points, such as 3, 7, and -2, 8. Remember, for your points, you always have your x and then your y value. So if we want to do this, we're going to use that formula we looked at earlier. M equals y2 minus y1 divided by x2 minus x1. Now I'm going to let 3 and 7 be my x1 and my y1, and -2 and 8 be my x2 and my y2. I could have flipped those around, but that's what I picked. Now I just plug them into my formula. So y2 minus y1 is 8 minus 7 over x2 minus x1, which is -2 minus 3. And from there, I just compute. 8 minus 7 is 1. -2 minus 3 is -5. Well, I can write that as -1/5, and that is my slope. Now we're just going to look at a couple more examples. So we just talked about how to find the slope from a line. So we're going to find 2 points. We're going to figure out how far up or down we have to go, and then how far over. So here's a point right here. Well, to this next point on our graph, we go up 1 and over 2, which makes our rise 1 and our run 2. So this tells us that the slope of this line is 1/2. We do the same thing for our next graph. We find a point and figure out how far up or down we have to go. Well, from this point right here, we always work from left to right. So from this point farthest left right here, we go down 2 and we go over 2. So our rise would be -2. Negative is how we express going down. And our run would be +2. Well, -2 divided by +2 is -1, so our slope is -1. Now we're going to use that formula, so you want to start practicing that formula. M equals y2 minus y1 over x2 minus x1. So if we want to find the slope for -6, 3 and -5, 5, we're going to label our points. So this time I'm going to say -6 is my x2, 3 is my y2, -5 is my x1, 5 is my y1. Then I just plug them in. So I would have 3 minus 5, m equals 3 minus 5 divided by -6 minus a -5. Be careful for your negatives. 3 minus 5 is -2. Well, my negative or minus a -5 is going to be the same thing as +5. So -6 plus 5 is -1. If I simplify -2 and -1, I get a +2. So our slope m equals +2. Then we do the same thing. Okay, just using that formula again. So this time, 0.8 will be my x1, y1. 2.8 will be my x2, y2. So m will equal 8 minus 8 divided by 2 minus 0. Well, 8 minus 8 is 0. 2 minus 0 is 2. 0 divided by 2 is 0. So all we did was compute that, and we found our slope m equals 0. Just to review, your slope, it's the same thing as rise over run, and it tells you your rate of change, so how fast or slow something is changing. Also, I would start practicing this formula. We are going to be using that a lot this coming unit.